Hi everyone, welcome back to Chem Help ASAP. In this video we are going to be naming simple binary covalent compounds. Now I do want to caution you and just be upfront that we will be naming some wholly imaginary compounds, mostly because I want to practice using different prefixes, and so I just made up some examples that do not exist in the real world. However, we can still apply our naming rules to them. So let me show you. Before we jump into the naming, of course, let's go over our rules for naming these compounds. So the first rule is we are going to name the first element with its elemental name. Now notice this is different from ionic. The first element is not a cation because these are covalent compounds, not ionic compounds. However, we are still going to name the first element with its elemental name. The second element, we are going to change the ending to IDE. Again, very similar to ionic, however, these are not cations and anions anymore. Our third rule states that we will use prefixes to specify how many atoms of each element we have in the compound. So if you look to the left-hand side of the screen, you can see I have listed the prefixes out from 1 to 10. There are two modifiers to this prefix rule. The first one is that we will drop the mono if the first element happens to just have one atom. The second modifier is simply to make the name a little bit easier to write and pronounce. You'll notice the prefixes all end in vowels, and sometimes our second element starts with a vowel. So we will drop that vowel so we don't have two vowel sounds together. So instead of having monooxide, we would simply call that monoxide. However, we will see this in practice with our examples. My first example, you could probably name without knowing any of the naming rules. You probably have known this compound since elementary school. CO2, again, you know that is carbon dioxide, but let's see how the names play out. So if I'm following my rules, I'm going to name the first element with its elemental name. C, I recognize as carbon. I'm going to name the second element with an IDE ending. Oxygen becomes oxide. Now I need to use the prefixes to tell the reader how many of each atom I have. Now if I look at my carbon, I see that I only have one carbon. Aha, this is actually one of my exceptions up here. I am not going to write mono. I am going to drop that mono. It is going to be understood. If I look at my oxygen, I see that I have two oxygens. My prefix for that is di, hence carbon dioxide. Let's move on to my second example. SO3, S I know is simply sulfur. Again, oxygen becomes oxide. And now I need to use my prefixes to tell the reader how many of each of these atoms I have. The sulfur, I only have one. Again, I'm going to drop the mono there. My oxygen, I see that I have three, so this becomes sulfur trioxide. Now for my next example, P3Cl5. P, I know, is simply phosphorus. This is going to be a rather long name. I think I'm going to use two lines here. Cl I recognize as chlorine, but I need to change that ending to IDE, so that will simply become chloride. Now I need to use my prefixes to tell the reader how many of each I have. So for phosphorus, I see I have three, so that will become triphosphorus. For chlorine, I see that I have five. Here, if I go to my prefixes, I see that 5 is penta. So this compound is triphosphorus pentachloride. Last example for molecular formula to name, SF2. S I know is sulfur. F is fluorine. Again, I changed the ending to fluoride. I drop the mono in front of sulfur. Fluorine, I have 2. That becomes difluoride. Sulfur difluoride. Let's reverse gears. Let's go from the name to the molecular formula. Again, I'm starting with one that you already know, carbon monoxide, but let's use our naming rules for this. Carbon, I know, is C. I already know there's one carbon, and then the mono has been dropped. When I look at oxide, I know that is O. Again, the mono here tells me I just have one, so I have one carbon, one oxygen, carbon monoxide. Again, notice here that it's not monoxide, it's monoxide. We've dropped that extra vowel there. Let's take a look at my second example, dinitrogen tetroxide. Nitrogen, I know, is N. The di here tells me there are two. Oxide tells me that it is oxygen. Again, the vowel was dropped. That's tetra. Tetra over here I can see is 4. That is N2O4. My next example, tetranitrogen hexabromide. That is a mouthful. Nitrogen is N. Tetra tells me there are 4. Bromide, that's Br. Hexa up here tells me that there are 6. Last example, trisulfur heptachloride. Sulfur, of course, is S. Tri means there are 3. Chloride simply comes from Cl. Hepta here, again, you can find it over here, means that there are 7. Most students find the covalent naming the easiest naming because the name gives you how many of each atom. So there's no math involved in trying to figure out what the charge is on an ion or how many of each ion you need. If you would like to learn more about how to properly name larger organic molecules, I encourage you to go check out Erlen's video. He does naming with all of the different functional groups, and you can properly name those large organic compounds with him. However, for our purposes, we simply stick with these simple binary compounds. I hope this was helpful, and thank you so much for watching.